Assalamu alaikum students. The topic taken for today's video is moment of a force, the principle of moment and work done. Let's see first what is a pivot or a hinge. You can apply a force and turn an object about a pivot or a hinge. So the point from where you can rotate an object, that point is called as the pivot. You can see in this image, the image is of a spanner, and the pivot is at the center of the spanner to the left, and when you apply force on the opposite side, you can turn the whole spanner around that pivot. When you can turn something by applying a force, it is called as moment of a force. So the turning effect of a force is called the moment of a force. You may add on the definition by using the words hinge or pivot. The turning effect of a force about a hinge or pivot is called its moment. So this is the definition of moment. Now let's see what's the formula for moment of a force. Moment of a force is the product of the force which is applied to the object and the perpendicular distance from the point of pivot. So that means moment of force is equals to force applied into the distance, that is d. Since force is in newtons, the distance should be in meters, and therefore the units of moment of force is Newton meter. So we can use a triangle formula to write the formula for moment of force, where moment of force is right up in the triangle, and on the base of the triangle you have force into distance. This distance is the perpendicular distance from the pivot, and the force is the force applied by us on the object. So using this triangle formula, if we want to know the formula for force, if moment and perpendicular distance is given, then the formula for force will be, you hide force. If you keep a hand on force, you will see moment divided by perpendicular distance. So we can derive another formula for force, that is force will be equals to moment divided by perpendicular distance. Similarly, we can derive one more formula for distance. If moment and force is given and we want to calculate the perpendicular distance from the pivot, then if you see the triangle formula, if you hide d, you will see moment divided by f. So the formula for distance will be moment divided by the force. So from one formula you can derive two other formulae. So basically the main one is moment is equals to force into perpendicular distance from the pivot. Now let's see various examples. Here the rod, which is 4 meter plus 6 meter, so total 10 meter rod, is kept on a support on that green triangle. The green triangle here represents the pivot. So it's like a seesaw. So the seesaw can move right and left about around that pivot with the help of that support which is in the center, which is called as the pivot. Now rotations are possible in two ways here. One is clockwise rotation and the other is anti-clockwise rotation. Clockwise is from right to left and anti-clockwise is from left to right. So here if we want to calculate the force on clockwise, in the clockwise direction, what will be the moment for clockwise rotation? It will be force into distance. So for clockwise you can see force is given in newtons is 50 and the distance is 6 meter. So moment, clockwise moment is 50 into 60, that will give you 300. 5 6 is 30. So 300 Newton meter will be the moment of force clockwise. Now let's see what's the moment of force anti-clockwise. For anti-clockwise the force is 80 newtons and distance is 4 meter. So 80 multiplied by 4 gives you 320. 8 4 is 32 and that's 0. So 320 Newton meter is the moment anti-clockwise. So like this, using the distance and the force, you can calculate moment of a force. So here it's elaborated more that the center point is the pivot. Now there is a principle of moment of force, and that principle is whenever there are two forces acting on either side of the pivot, the forces can be balanced or they can be unbalanced. So the principle of moment says that total of anti-clockwise moment is equals to total of clockwise moment. If this is so, then the forces are balanced. So the principle of moment is, instead of using the word total, you can use the word sum. Sum of clockwise moment is equals to sum of anti-clockwise moment, then the forces are balanced. Let us see this example here now. The pivot is the triangle which is black in color, and then again there is a force of 4. Let's see the clockwise, okay, right hand side of the pivot. The force is 4 Newton and the distance is 2 meter. So what will be the moment, clockwise moment? Clockwise moment will be force into distance, that is 4 into 2 will give you 8 Newton meter. Now let's move on. So 8 Newton meter is moment clockwise. Now let's see left hand side of the black triangle, the pivot, that is anti-clockwise. So the moment, anti-clockwise moment will be, what's the force at on the left hand side? It is 2 newtons while the distance is 4 meter from the pivot. So 2 into 4 gives you 8 Newton meter. So here the clockwise moment is 8 Newton meter and anti-clockwise moment is also 8 Newton meter. So when clockwise and anti-clockwise moments are equal, then we say that the forces are balanced. So this is the principle of moment. Let's see now one more example. Here on a seesaw, a boy is sitting on the anti-clockwise side of the seesaw of the pivot, and the pivot is at the center. The force on the pivot is 200 newtons. We'll ignore that. Wait, now we'll just see the forces on the right and the left, and the girl's weight, the force acting on the girl is 300 newtons. Yes, and she's sitting on the clockwise side. Now let us find the moment of, let's say, girl first. Okay, what will be the moment for the acting on that girl clockwise side? It will be force into distance from pivot. Girl's force is shown with the arrow down. It is 300 Newton and her distance from the central pivot is 1.5. So 1.5 multiplied by 300 gives us 450 Newton meter. So the moment of force acting on the girl is 450 Newton meter. Now let's see what's the force on the boy. What's the moment of force on the boy? To calculate moment of force on the boy who is sitting on the anti-clockwise side, again what you need to do is you need to multiply force by the distance. The force given near the image of the boy is 450 and the distance from the pivot, the boy's distance from the central pivot is 1 meter. So 450 into 1 is 450. So your clockwise moment is again equals to anti-clockwise moment. Both the moments are coming same, 450 Newton meter, 450 Newton meter. That means this seesaw is a balanced seesaw because it has proved the principle of moment of principle, that is sum of clockwise moment is equals to sum of anti-clockwise moment. Now let's move on to the next small subtopic, and that is work done. When work will be done? Whenever we want to do any work, we need energy. So the amount of energy which we are transferring on an object is called as the work done. So the simplest definition of work done is amount of energy transferred. Now this work done can be a mechanical work done, it can be an electrical work done, it can be work done when we are transferring energy from our muscles, muscular force we are applying. So there are different types of forces which are applied and then work can be done. So the formula for work done is force into distance moved in the direction of the force. Here we will only talk about the work done by us. If we are doing something, we are applying force and we are moving a particular thing from a specific distance. So in that case, what will be work done given as? Work done will be equals to force into distance moved. The units for work done is joules, that is capital J. Force is in newtons and the distance moved will be in meters. So isn't this formula similar to the moment of the force? Yes, it is similar. Moment of force was force into perpendicular distance from the pivot, and here work done is force into distance moved, to how much ever distance we are moving that object. Let's see few examples, numericals on work done. A teacher applies a force of 50 Newton to move a student's bag 10 meter. So a teacher applies a force of 10 Newton to a bag and the bag changed its position. Okay, it moved 10 meters away from the original point. So the distance moved is 10 meters. How much work is done? Okay, before finding the actual work done, you should see the units. Okay, the force is given in newtons and distance should always be in meters. Then only you can use these values in the formula. So what's the formula for work done? Work done is force into distance moved. Work done is 50, force is 50 into distance is 10. So 50 into 10 gives us 500. So how much work is done to shift that bag? It's 500 joules. The unit for joules is, the unit of work done is joules and it's written by capital J. So in this manner, numericals on work done can be solved. Let's see one more last example now. You are helping to push your mother's heavy shopping cart with a force of 50 Newton for 200 meters. So usually when you take a cart or you say a trolley, okay, in malls, and you are moving it with a force of 50 Newton and you moved that cart or a trolley to 200 meters. Let's calculate the work done by you in helping your mother. So you need to write the formula first. Work done is force into distance moved. Here S is representing the distance. You may write D or S, small d for distance moved. Force is 50 Newton, so we write instead of force its value as 50 multiplied by the distance here is 200. So 50 into 200 gives you 10,000 joules. So the work done is 10,000 joules. Now 1 kilojoule is 1000 joules. So if you want to remove those 3 zeros, and you may write the answer as, instead of those 3 zeros instead of 10,000, you may remove the 3 zeros and you may write the answer as kilojoules also. So to convert joules to kilojoules, if you have many zeros, you can divide the answer by 1000. That joules gets converted to kilojoules. So if you divide 10,000 by 1000, 3 zeros gets cancelled and you're just left with 10. So the work done is 10 kilojoules. So students, in this manner, we saw how to calculate moment of a force, the turning effect of a force about a hinges. The moment of force, its formula is force into perpendicular distance from the pivot. Its units are Newton meter. Then we saw what's the principle of moment of force. The principle is sum of clockwise moment is equals to sum of anti-clockwise moment. And finally, we saw work done is the equals to force into the distance moved. Thank you.